Let's review what we know about curve sketching thus far, and then we'll move forward, adding details to the graph by using the second derivative. So remember, when you are curve sketching, the first thing you do is simply find f prime of x. Then you take the derivative, or after you take the derivative, you look at where f prime of x equals 0, solve for those x's, and also look at where f prime of x does not exist, find those x's. Those x's are called the critical values. We'll say that the critical values are listed here as x sub 1, x sub 2, and x sub 3. In general, what you do is you pick test values between them, and then you plug them into f prime of x, see if it's positive or negative, and then you infer if f prime is positive that f is increasing, and if f prime is negative then f is decreasing. I can then, once I have a table completed, I can say where the function is increasing and decreasing. I can name the x values at which I have maxes and mins. I can plug those x's in to find y values if I need complete points that are maxes and mins, and then I sketch. We're doing the same thing today, but we are adding the second derivative. So officially, when a function is concave up, it's defined as y prime increasing over an interval. But remember what you know. If y prime is increasing, so if a function is increasing, its derivative, now wait a minute, the derivative of y prime would be y double prime must be positive. So remember, if a function increases, its derivative is positive. And then if a function is decreasing, its derivative must be negative. And remember, the derivative of y prime goes to y double prime. It's what I've got double underlined that I use when I'm thinking about concave up and concave down. So I'm going to connect y prime is increasing, means y double prime is positive. And if y double prime is positive, then concave up. And that's for y is concave up. So I don't think of concave up being when y prime is increasing. I think of it as when y double prime is greater than 0. That's the link I make. Now, I do the similar thing for y double prime is negative. Y double prime is negative means concave down for me. That's the connection that I make. So what I'd like to do is just consider two functions that are already familiar to you. Now, we know that y equals x squared is a parabola centered at the origin. Its vertex is at the origin and it opens up. And you know what the shape is. But consider if you take the first derivative, you get 2x here. Second derivative, you get 2. 2 is a positive number. So y double prime is always positive. That means y equals x squared, the original function, is always concave up. Well, if you graph what you already know about y equals x squared, I can see that sure enough it's a function that is always concave up. So it fits what you already know. Now we know that y equals x cubed, for instance, is centered at the origin and it's this cubic shape. So if you match it to what you know, what you already have this picture of, if you match it to the algebra, again, I take y equals x cubed. First derivative is y prime is 3x squared. Second derivative is y prime double prime is 6x. Now, I'm going to say that the second derivative is 0 if x is 0. This is called a hypercritical value. Just like figuring out when y prime equals 0, you're finding critical values. When you find when y double prime is 0 or when y double prime does not exist, you're finding what's called hypercritical values. So I'm still going to wind up doing a sign chart for it. So let's pick test values here of negative 10 and positive 10. Well, notice that y double prime, 6x would be 6 times negative 10 would be negative. And then 6 times positive 10 would be positive. Now, instead of saying, well, that means y is decreasing and increasing, I say that means y is concave down and then y is concave up. And if you look at your graph, guys, then sure enough, when x is less than 0, I see a concave down shape. And when x is greater than 0, I see a concave up shape. So what I'm doing with my calculus matches the ideas I already have about these graphs. So I just want to reinforce that what you are learning matches the things that you already know. Now, I love the problem that I'm showing you right here. It's really not very work intense, but it really gets at the topics that we're talking about. So let's rank these in order from small to large. Now, if you're thinking, how in the world would I find f of 2? Remember, this is the graph of f of x. So I can see from the graph that f of 2 is just equal to 0. Well, how would you be able to tell anything about f prime of 2? I'll remind you that f prime of 2 would be the slope of the graph at x equals 2. Well, the slope is positive, and you'll notice if I drew in a tangent line, the slope is positive, but the other thing I know is if f of x is increasing, then its derivative is positive, so f prime of 2 is positive. Well, how in the world would you know anything about f double prime of 2? Well, again, the second derivative deals with concave up or concave down. Do you see that f of x is always concave down, which means that f double prime of x is always negative. So more specifically, f double prime of 2 is negative. So from low to high, I would need to put it in order from the negative value. That will be less than the 0 value. That will be less than the positive value. So there's my answer, ordering those in ascending order. Well, what I'd like for you to do now is get into your packets and find the document that says Multi-Representation of Functions Sample Problem 1996-AB1. Find that, and we're going to go through it together. Now, I'm going to move forward. If you need to stop the video for a second to find it, just hit pause, and then start me up again when you are ready to go. Now, if you look at the graph, what I have done is created a chart where for every single x value listed on the graph, I have gone ahead and put them in a sign chart. So I may not have needed to list every x value, but I'm going to list them just to be careful. Well, above the black line, what I'm going to do is record when the derivative is positive so that I can see when f of x is increasing and decreasing. So do you see on the graph that from -3 to -2, the derivative is above the x-axis, so it's positive? That means I know the function is increasing, the function I haven't graphed yet. Well, from -2 all the way to 1, do you see that f prime of x is below the x-axis and negative? That means from -2 all the way to 1, your original f of x function will decrease. Well, I noticed that from 1 to 4, the derivative is still below the x-axis, so my function continues to decrease. From 4 to 5, my function finally is positive again, which means my graph's going to increase when I get around to graphing f of x. Now, below the black line, we're going to handle this a little differently. I'm going to use f prime of x to figure out what's going on with its derivative. So, for instance, do you see on my f prime of x graph, from -3 to -1, f prime of x is decreasing. That means its derivative is negative. You might say, why are you doing that? Because remember, if the second derivative is negative, the top level function is concave down. So I'm trying to move from the derivative in my thinking to the second derivative so that I can move from the second derivative to shape of the first function. So let's see here. From -2 to -1, oh, still decreasing. I think I said that but didn't write it. All right. Now from -1 all the way to 1, my function is increasing. My derivative function, that is. That means its derivative is positive. And if the second derivative is positive, that means the whole function, the original function's concave up. Now, I notice from 1 to 3, my f prime of x graph is decreasing again, which means its derivative, the second derivative, would be negative. And if the second derivative is negative, my top level function, f of x, is concave down in shape. Last but not least, from 3 to 5, f prime of x is increasing. That makes f double prime of x positive, and that makes f of x greater than, not greater than 0, but concave up. Now, let's try to answer some questions before we go to the graphing phase of this problem. So for what values of x does f have a relative max? Well, look here at the second row of the table. If I have a max, that means the graph increases and then it decreases. So do you see if the graph goes up and down, then I would have to have a max right here. I could also look and say if the graph goes down, then turns and goes up, it would have to have a min. So on part A, I'm going to say that a max occurs at, let's see, that would be x equals -2. And when it says justify it, just say, okay, well, because. Now, we would like to say that it's because f of x increases and then turns and decreases, but they won't let you say that on the AP exam. They'll say, we've given you f prime of x, so put your answers in terms of f prime of x. Make it your reason. So I have to say because f prime of x changes from positive to negative. Well, if you look at part B, where is the min? Well, we already know, and you probably already know how to answer this. So you would say the min is at x equals, I heard you say 4. You're doing a good job. Now, why is that? Can you finish the because part of this statement? I hope you are writing f of x changes, f of x, my bad, f prime of x changes from negative to positive. All right, so I'm going to create or flip to the second slide, and I have recreated my chart here so I didn't have to keep flipping back and forth between the first and second slide. So on to part C. On what intervals is the graph of f concave up? Use f prime to justify your answer. Well, it's easy enough for me to say, look at the little right side up U shapes. That's where the graph is concave up. So I'm going to have 2 intervals. Let me say that f of x is concave up on the intervals. Let's see, it looks like from x equals -1 to x equals 1. Union, and then it says from 3 to 5. Now, what I would like to be able to say is that happens because f double prime of x is positive, but that's not what you can say. You've got to go back again because they've given you f prime of x information. You've got to base all your reasoning on the f prime of x graph. So I have to say because f prime of x, let's see here, remember f prime of x in these intervals was increasing on both of those intervals. So instead of saying is increasing, I'm going to say increases and leave it there. Now the last part of the question is the most interesting in my mind, and I'm going to do more than it asks you to do, because it asks you to graph just a part of the function from 0 to 2. We're going to go ahead and graph everything from -3 to 5 because I think it will be helpful to you. So I'm tick marking as I assume that you are doing. Now, one thing that's nice is it tells you that f of 1 is 0. And what they're telling you is if f of 1 is equal to 0, of course, put the point 1, 0 on your graph. So they're giving you a place to anchor the graph. Otherwise, we could get the shape of f of x, but we wouldn't know exactly where to put it from top to bottom, like where do those y values go. And you're still not going to know exactly where, but this will at least anchor the graph. I'm going to suggest, before we do anything else, you may want to remember that we said you're going to have a max at -2. So I would say just put some kind of a random point at -2 that's high and call that a max. Well, how high? I don't know. We don't know. We don't have enough information about f of x to know where the y values are. So just any place is fine. I would put it higher than 1, 0. Now, we also mentioned that there was a min at 4. So again, I'm going to pick a place and I'm going to say, let's let this point be my low point min. And then I'm going to go from there. So what I will do, I'm reading and making sure I'm not in, no, I'm not. I didn't want to miss any other information that it might ask me. So what I'm going to do is say, for each -3 to 2, then -2 to 1, for each small interval, I am going to graph it one at a time unless there are no changes. So I see from -3 to 2, it's increasing, then from -2 to 1, it decreases. So I'm just going to do the one interval first. So I know that it increases and is concave down from -3 to -2. So from -3, and it doesn't matter. I'm going to put -3's y-coordinate right there. And it doesn't really matter how you do it. But to -2, and that's my max, I need my graph to increase and be concave down in shape. So it would look like this. Now, it says that the graph is going to decrease and be concave down on the next little one-step interval. And there's a change from -2 to -1, then -1 to 0. So I'm just, again, doing one jump at a time. So I need to decrease in a concave down shape. Well, I don't know how far down to go for -1, so maybe I'll stop right here and put the y-coordinate there. But I need it to decrease and go concave down. Now, I notice that the next two intervals, from -1 to 0 and from 0 to 1, both of those are decreasing and concave up. So I'm going to do that as one large interval. So I need to go from -1 to 1. So from the orange point to the green point, decreasing, obviously, I've got to go downward and be concave up. So it would have to be this kind of shape, concave up. Now I see that on my next two intervals, again, it's decreasing on the next two intervals and concave down. So I'm going to put them together like it's one big step. So from 1 to 3, I need to decrease and go concave down. Well, if I'm decreasing, I've got to go below 3, or below, in this case, the x-axis. But I don't want to go as low as the min, because I need the min to be the low point. So I'm going to make the graph go downward and be bowl-shaped down. So it'd be like that. Then I see on the next interval, it continues to decrease, but it's going to be concave up in shape. So I need to go to the min, going down to the min, concave up in shape. Last but not least, the graph's going to increase and be concave up. So from my black min onward, it's going to increase and be concave up. I don't know where 5 should be, so I'm going to make it 5, 0. And again, it doesn't matter. As long as you have the right shape. The placement of your points does not matter except for the one that was given at 1, 0. So that's how you piece the concave down, concave up, and the increasing, decreasing. That's how you piece those concepts together. So we're going to stop here. I want you to get together with one or two partners, and I want you to work on the next problem in your packet, which is the 1980 problem. Do it similarly, and then you'll be able to check your work. So take like 10 minutes.